Thank you. And then just to also let you know, something else our CAC does is Maya has been sitting on the committee since November or December, helping us plan the symposium. So behind the scenes, the Stewardship Foundation, the Forest Service sits on the committee, and Maya does as well. So a lot of people making today possible, including our next speaker, who is Sarah Schoen from USGS. We're going to talk about marine food webs and climate change in Prince William Sound.
All right, thanks. Okay, thanks. All right, thanks so much for having me today. Again, my name is Sarah Schoen, and I'm at the U.S. Geological Survey Alaska Science Center in Anchorage. And my boss, Yumi Aramitsu, was originally signed up to talk today, but is unfortunately unable to join us, but I'm happy to be here instead, and I'm going to try to do justice to the talk that she put together. So I'm going to talk to you about seabirds as ocean sentinels. So the most well-known example of a sentinel of change is probably the canary in the coal mine. So John Haldane's research on carbon monoxide led him to recommend using a sentinel species, one that was more sensitive to poisonous gases than humans, as an early warning signal. And canaries were used to alert miners about whether the air in the mines was safe to breathe from 1911 to 1986. And those canaries were really perfect because they were small size, easy to transport, and they had this physiological need for a huge amount of oxygen. And we believe that seabirds are similarly well suited to serve as sentinels of change in the ocean. These are large-bodied birds that really have high body temperatures, and they have a really, really high metabolism. So they require a lot of food in order to keep up their condition. And they're particularly sensitive to the changes in the environment, like the changes in the abundance and distribution of their food. So on January 1st, 2016, retired Fish and Wildlife Service biologist David Irons was in Whittier with his family, and he noticed a huge wreck of birds at the head of Passage Canal. And David and his family counted almost 7,800 murres just at the head of Passage Canal. In that one location. So for reference, to give you an idea of scale, Gull Island, which is the seabird rookery just across from Homer and Katchmack Bay, had an estimated breeding population of just over 7,600 murres in 2016. So that one beach, two beaches at the head of Passage Canal that David and his family counted in 2016 was the equivalent of an entire colony of murres dead. And of course, that wasn't the only location. That die-off spread from the Bering Chukchi Seas all the way south to Southern California. In total, a huge group of different organizations and citizen science programs and collaborators counted about 62,000 dead and dying murres in those 2 years across those beaches. You can see some of the largest numbers of birds were found in Prince William Sound. That really big circle here is in Prince William Sound. And in general, the Gulf of Alaska was really the geographic center of this die-off. And then in the years following this die-off, our colleagues Heather Renner at the Maritime Refuge and John Pyatt have been working on a project looking at the recovery of populations at colonies, and they're estimating that 3 million murres are missing from colonies. So it's possible that this die-off actually killed up to 3 million birds. So following this unprecedented die-off of murres, our research program at the USGS Alaska Science Center aimed to quantify the scale and magnitude of the die-off event. When we first heard about the die-off, we quickly sprung into action and chartered the Alexandra, and the Von Wickmans took us on a tour of Prince William Sound in lovely, balmy January weather of 31-degree rain. And we crossed the sound as quickly as we could in a couple of days, counting birds, and it was really amazing in a sad way how many birds were found. The highest density of murres we found was in Piggott Bay, and just piles and piles of birds. And then we followed this up with more surveys across Alaska beaches, trying to figure out how far the die-off had spread, and flew down the Alaska Peninsula, counting birds on beaches, and we just saw birds on nearly every beach we looked at. So we also wanted to investigate the underlying drivers of the die-off. The birds that we were finding were all starving, they were all skinny. So we knew that food had played a factor, but we were also investigating things like the role of harmful algal bloom toxins. And then we also wanted to look at population impacts of the die-off, in particular for years following the die-off. We've been following population estimates and productivity, reproductive success at 2 colonies in Lower Cook Inlet for years following this die-off. And we found that the colony attendance hasn't rebounded in the 6 years that we've been monitoring it. And the reproduction of birds that are attending is also not normal. So we've had a lot of years of failure, but even when the birds are able to successfully fledge chicks, it's at rates that are much lower than the historic averages. So I want to share a summary video that we put together with a student, Bella Lazinski. Bella was a federal service program student, and she did a great job with this. So I'm going to play this for you now.
In 2015, the public noticed thousands of dead seabirds washing ashore across the western coast of the United States and Canada. The U.S. Geological Survey later linked this massive seabird die-off to the North Pacific marine heat wave. A marine heat wave occurs when sea surface temperatures are above normal for an extended period of time. This marine heat wave caused ocean temperatures to increase far above normal from 2013 to 2016, making it the longest marine heat wave on record. This sharp increase in warm water impacted prey communities, especially forage fish, and contributed to the starvation of an estimated 1 million common ears from Southern California to Alaska. During the heat wave, key forage fish such as keeplet and salmons were less abundant and smaller in size than before the heat wave. Smaller reproducing keeplet tend to lay fewer eggs, which could have reduced their ability to produce offspring. Meanwhile, salmon populations were composed of much smaller fish than in some areas. Their lack of growth greatly reduced the amount of fat and energy available to seabirds that rely on them as food. These changes to forage fish populations may have been due to bottom-up factors, such as warmer water coinciding with a decrease in size and energy content of the zooplankton that the fish feed on. At the same time, larger forage fish individuals were missing from the ecosystem. This may have been due to top-down factors, such as predation from larger fish that needed to eat more due to the increased metabolism in the warmer weather. These combined top-down and bottom-up factors resulted in an overall reduction in several key forage fish species, and this was the primary cause of the major seabird die. A seabird that primarily feeds on forage fish. Likely died from starvation, as the majority of the carcasses examined had empty stomachs and no body fat. Additionally, some of the seabirds contained mostly low levels of saxitoxin, the toxin that causes paralytic shellfish poisoning, which is produced by harmful algal blooms. Although the primary cause of mortality was starvation, the algal toxins could have been an additional stressor during the marine heat wave. The USGS continues to investigate the harmful impacts of algal blooms on seabirds and their food webs. Seabirds serve as ocean sentinels and are indicators of the health of the marine environment. The USGS is studying the impacts of the marine heat waves on ocean food webs using seabirds and their prey as key indicators. Such studies assess the health of northern waters that are important for commercial fisheries and Alaskan native subsistence. These efforts allow citizens, scientists, and resource managers to better understand and anticipate future responses of marine ecosystems to warming global temperatures. If you'd like to learn more about the North Pacific marine heat wave, please visit the links below.
Okay. As part of the Gulf Watch Alaska long-term ecological monitoring program, we've been collecting data on forage fish abundance and condition in order to better understand how the abundance and nutritional quality of these key prey species change over time. And this information is helpful for understanding predator-prey interactions, especially in light of these recent seabird die-offs. So alongside this murre die-off, there were shifts in distribution, breeding failures, unusual mortalities, and malnutrition throughout the higher levels of the food web, including in predators like Pacific cod and whales. And these birds were what were alerting us to these issues in the ecosystem that we wouldn't have known about without such visible cues, like seeing thousands of dead birds across beaches. And an example of a decline, these mortalities and declines in stocks, the Pacific cod stock biomass decreased by 83% in the Gulf of Alaska from 2013 to 2018. So at the same time as we saw these impacts, the higher predators that I just talked about, we also saw changes across the forage fish community. So we saw declines in abundance, lower energy content, shifts in the age structure, changes in growth, size, age truncation, and a loss of cold water species. And Bella talked about that in the video, some examples. But in general, the zooplankton, the fish we're feeding on, were dominated by small-sized warm water species that had lower lipid content. That was the bottom-up influence. And then from the top down, there was a lack of older and larger forage fish individuals, and that could have been due to these increased metabolic demands because the requirements for predatory fish were increased with the warmer waters. So to put all of these biological effects into perspective, we of course need to think about the physical environment. This graphic here shows sea surface anomaly data from July 2015, which was right at the height of the largest marine heat wave that had ever occurred at the time, called the blob. And that stretched from 2014 through 2016. And the highest category and most intense marine heat waves from that event were modulated by the El Nino Southern Oscillation. And we have to remember that this global warming signal is a driver for these marine heat waves. This graphic by Rob Campbell shows the warming trend for Prince William Sound, which is denoted with a star. And you can see in the figure, the global warming has increased the temperatures about 0.1 degrees Celsius per decade in Prince William Sound. And you can see in the last about decade, the anomalies are much warmer, the temperatures have been warmer a lot more commonly than they have been in the past. So then, of course, another part of our physical environment that's critically influenced by global warming is ice. The Kitlitz's murrelet, which is the bird in the big bird in the picture here, that's another sentinel species for us because of its use of sea ice and glacier ice habitats throughout coastal Alaska, and they even occur into Russia. Some Kitlitz's, so Kitlitz's and marbled murrelets, the marbled murrelets in the small photo there, they're both found in Prince William Sound. Marbled murrelets are more common, and these two species can be challenging to tell apart. But just a quick primer on that. The Kitlitz's have bigger eyes, shorter bills. They're more mottled in their plumage, and they have white outer tail feathers. So these two species have some overlap in habitat use, but Kitlitz's generally have a closer association in ice than marbled murrelets do, and their range expands farther north than marbled murrelets. And in this picture, you can see those white outer tail feathers that I was talking about here, which are only visible in flight. And this bird is also holding a capelin. Both species, marbled and Kitlitz's murrelets, feed on krill and small forage fish, but capelin are especially important due to their high fat content. And capelin are a species of fish that's associated with cold water and oftentimes glaciated habitat, which includes habitat in Prince William Sound and in the Arctic. So we've been studying Kitlitz's for years, and I just want to talk to you about one of our projects, which use satellite tags to help understand the migratory pathways of Kitlitz's and their marine habitat use in Alaska. So in the photo here, this is a satellite tag attached to the back of a murrelet with sutures, achillises. And in this graphic here, we have time of year on the x-axis, May through October are the dates that we tracked birds. And then we have each row on the y-axis represents a different bird, individual bird that was tagged. And the open symbols are colored by the marine ecoregion that they occupied before they migrated. And the closed symbols are colored by the ecoregion that they occupied after they left their breeding location. So all of these orange boxes here, the highlighted data, were birds that were tagged in Prince William Sound. So during the peak of the breeding season, most birds, most killises are found in the Gulf of Alaska. And then there's some in remnant breeding populations in deglaciated areas like the Western Aleutians, and some even breed up into the Arctic. But the vast majority are down in the Gulf of Alaska. And after the breeding season, we were really surprised to see our tagged birds all go west and north. All of the birds migrated north into the coastal waters of the Beaufort and Chukchi Seas. And in the course of their migration, they crossed 10 marine ecoregions on the way. And you can see those ecoregions color-coded in the map of Alaska here. So these birds are really remarkable in that they concentrate at the sea ice edge in the non-breeding season, as opposed to migrating south like most birds do. And their seasonal use of sea ice and glacier ice makes them a really good ocean sentinel. So this figure, or this photo, represents some of the important forage for murrelets. Capelin are the shiny silver ones, and they also smell like cucumbers. And myctophids are the other fish in the picture with the shiny little dots and the black, and those are phosphorescent photophores. So we use our research vessel, the Alaskan Gyre, to do midwater trawls where we're studying birds and fish. And this catch here that we're showing here is a catch that was found in Glacier Bay, right near a glacier. So glaciers provide really important habitat functions in marine ecosystems. And here I'm going to describe some of Yumi's dissertation research on glaciers. Yumi worked with Bruce Nelson, a local artist from Kodiak, to make these really beautiful paintings that describe the concepts of scale-dependent interactions that Yumi talks about in her dissertation. So on the left photo or painting, that's depicting the glacier influence on a local scale, so under 10 kilometers from glaciers. And at that scale, breeding seabirds are feeding on dispersed krill and forage fish in the turbid plume waters of the glacial water. And calving ice makes prey available to surface feeding birds like gulls, and it also provides habitat for pupping seals. And then in the top right here, that painting shows glacier influence on the fjord scale, so up to 100 kilometers. And there are persistent regions of marine productivity and dense predator-prey aggregations in those areas where there's mixing of fresh and marine waters. They're also characterized by large tides, constricted passages, and shallow sills that mark the previous termini of glaciers. And those replenish nutrients for phytoplankton growth where there's more light in the water column because the glacier sill settles out. And then on the bottom right, that painting represents glacier influence on a basin scale in the hundreds of kilometers from glaciers. And the seasonal change in discharge volume and windstorms influence circulation and induce iron exports to sea with rivers, eddies, and glacial dust transport. So iron from that dust promotes offshore phytoplankton blooms that fuel higher trophic levels, including commercially important fish and other wildlife. And also, of course, glaciers are an important and growing tourism industry in Alaska. So one glacier habitat that we've been studying for years is in Columbia Bay in Prince William Sound. We've tagged Kitlis's murrelets in Columbia Bay, and we've done oceanography and hydroacoustic trawl work there. And we've also tested samples for harmful algal bloom toxins. So Columbia Bay used to be the largest tidewater glacier in Alaska, but as you can see from these photos, even it's receded a lot lately. And even in the span of the 6 years that 6 of the years that we've worked there, you can see just how big of a difference there is in the ice extent from these pictures. So on that note, it's important to really emphasize that change is here. As of last month, the world's oceans are the hottest that they've ever been. And that's alarming for a lot of reasons, but we're also predicted to have another strong El Nino this summer, which would increase water temperatures and precipitation even more. So this situation is kind of setting us up to have a similar ecosystem disruption as what was caused by the blob. So it's really time to get serious about doing whatever we can to try to curb global warming, which means curbing our carbon dioxide output. And I encourage everyone to educate yourselves by reading things like the IPCC synthesis report that I have a tag to here, and that stands for the Intergovernmental Panel on Climate Change. And lastly, I just want to thank the many colleagues, collaborators, boat captains, contractors, and volunteers who have helped us over the years. This kind of ecosystem work takes a big team to do, and we appreciate the help of all the folks that worked on it. So if I have time for questions, I'm happy to take any.
Sarah, can you hear that?
I can't, nope.
Okay, so we're interested in the sea surface water temperature data and if there's a way to access that from the public, right?
Yeah, those data, so Yumi put that together, but NOAA has great web-based interfaces where you can put in the region that you're interested in and the time frame that you're interested in and the type of data that you want to look at. And you can get great info, real-time info from that website. I'll try to find a link and put it in the chat. But yeah, the graphic of the hot Earth in the beginning that came from NOAA. It's all available online to the public. So yes.
Are there questions in the room? I have a question, Sarah. When you're talking about, even in the last week or so, there's been more talk about an impending El Nino, and then I saw maybe increased chance for a significant one. Can you talk at all about that? What you've seen for El Nino predictions?
I can't really. I've read a couple of papers recently talking about it. It sounds like a moderate to substantial El Nino is really likely, but I can't, I'm not not an expert in that. Sorry, I can't talk to you about it more. I'm just nervous about that with these. I saw a graph looking at the ocean temperatures as of April of the last month, and our current temperatures are just deviating from the norm by a really alarming rate, and that gets scary when you think about adding an El Nino on top of that.
And when you talk about those ocean temperatures, are you talking about in the Gulf locally or broader than that?
That was global ocean temperatures that they were looking at as of last month. Those were the hottest on record. There is a ton of variability depending on a specific local area, but this isn't a trend that is different in different places. I'm sure that the magnitude of change is slightly different depending on the local environment, but my group has been looking at changes in ocean temperatures in lots of different areas. We've done a big project in Lower Cook Inlet, so we looked at marine heat waves across time in that location, and that's known to be a cold water refugium. So there's a lot of Alaska coastal current and upwelling in that area, and even there, it's at the same. The trends are the same. The dates, and years where the trends are higher are slightly variable depending on the specific location. But yeah, everything's warming.
Any other questions here? Thanks for that. It's just a great presentation and really helpful. And thanks for providing the information, the links to IPCC and just how all that's connected to our world here. So thanks to Sarah.
Thanks for having me.